Welcome to the review for the graphing exponential and log formative. Alright, so we're going to do some problems to help you do your best on the formative. Here's our first one. What's the equation of the graph? We have 2 points here. We have 1, 0, and we have 10, 3. Right, so the fact that we have 1, 0 means the graph is not shifted. It could be stretched because that won't change the point, the fact that the log function goes through 1, 0, but it's not shifted. So now all we have to do, we need to figure out if there is any there's any stretching. We need to figure out the base. Let's just put B for base. But that's about it. All right. So let's take a look at our point here. We have the point 10, 3. Right? So in other words, we raised a base to a power and got 10. Well, the only number I can think of that I could raise to a power and get 10 is 10. 10 to the first power. That would give us 10. But our y value is not 1, it's 3. Right? So if this were y equals log, and we don't usually write the 10, we just put x. If that was y equals log of x, it would go through, it's kind of hard to see these divisions here. And they're there. You can see it very, very faintly. You can see graph paper in the background, but it's really hard to see. So actually, let me graph in something other than red. So this, well, we were going just fine until it decided to glitch up. Let's see if I can move this piece in the right spot. Well, I could if that was where 1 was. Let's try it one more time. That's the best I can do. There we go. All right. So this here would be the graph of y equals log of x. But notice we didn't go through the point 10, 1. We went through the point 10, 3. That must mean our graph is vertically stretched by a power of 3. So now let's change our equation from y equals log x to y equals 3 log x. Let's see if that works out if we put in the point 10, 3. All right, so we got 3 as an answer for 3 log 10. All right, well, log 10, that's power I have to raise 10 to get 10. So this here equals 1. So 3 does equal 3 times 1. That checks out. It also, by the way, would check out with their other point, 1, 0. So 0 equals 3 log 1. All right, so this, oops, well, that looks nice, bracket there. This is log 1 there is the power I have to raise 10 to get 1. I'd have to raise 10 to the 0 power. So this would be 0 equals 3 times 0. And 0 does equal 0. So you can see that checks out. So you can always check out points when you're trying to match an equation to a graph. All right? Let's do another one now that you've done one. So these can be a little tricky, but you can always check a point, and that will give you an idea. And after we've done one, I think the next one gets to be a little bit easier. All right, well now we have the point 10 1/3. And if this were the graph, again, this look, we got 10 as a point here. We got 10 as an x value. I'm trying to move this up a little bit. It's not. So this is where, there we go. That's where the graph of y equals log x should go. And notice we only got 1/3 as much. Well, do you think this could be the equation? Y equals 1/3 log of x. Let's check it out with our points. All right, so if I plug in 1 0, so 0 equals 1/3 log 1. Well, again, I can't make a bracket very well. That equals 0. The power I have to raise 10 to get 1 is 0. And we have 0 equals 1/3 times 0. And 0 does equal 0. Let's check it out with our other point. So 1/3 equals 1/3 log 10. Well, this is the power that I have to raise 10 to get 10. So that's equal to 1. So we have 1/3 equals 1/3 times 1. 1/3 does equal 1/3. That checks out as well. So this must be the equation, y equals 1/3 log of x. I think I've got one more, but after you've done 2, I think you'll be an expert on number 3. Well, now our graph is going through the point 10 -2. Again, we see 10, so we should be thinking that 10 is going to be our base. Right? And remember, we don't write the 10. Y equals log x is the same thing, right? That has a base of 10. Right? And if this were the graph of y equals log x, again, it would go through the point 10 1, because when you raise 10 to the first power, you get 10. Y is the exponent. Oops. Y is the exponent. X is the result. Right? So 10 to the, and 10 is our base right here. So 10 to the first power does equal 10. But that's not all our graph is done. Our graph is reflected. And vertically stretched. All right, so now looking at taking our equation and realizing that we must have multiplied by something, because notice our graph isn't shifted. We went through the point 1 0. We're vertically stretched and we're clearly reflected. All right, so we have y equals a log, let's leave off the 10. Y equals a log of x. And so if our graph is, if our y value is negative and twice what it should be, it must mean that a equals -2. And that gives us the equation y equals -2 log x. On the formative, they really liked base 10, even though base 2 and base 3 are easier to work with because, well, I can only get 1 point in here. My next point is going to be 102. So for the base graph. So that wasn't happening. But if you had a base of 3, well, you'd have the point 92. But they seem to like base 10. Right? So find a point that you can work with, and then try to figure out how our graph was stretched or if it was reflected. Right? And if you're, let's say you have base, let's say you only don't include a whole lot of points, rule out what it can't be. All right, so if it's stretched, it's not going to be a fraction because that compresses. All right, if it's not reflected, it's not going to be negative. All right, it's going to be positive. So you can rule out some answers that way. All right, now what is the equation of the graph? Now this one is an exponential. So logarithmic go through the point 1, 0. Exponential go through the point 0, 1. All right, so we're going through the point 0, 1. This means the graph is not shifted. I also know that notice that the graph is headed towards the asymptote. All right, so as x approaches infinity, f of x is headed towards the asymptote, is heading towards 0. So this must be decay. And if our graph is decay, it means our base has to be between 0 and 1. Now here we have a point that really helps us out. So now we have the point 3, negative 1. All right, so, or excuse me, negative 1, 3. All right, so this is the x here, this is the exponent, this is the result, the opposite of log. So now, what could we raise to the negative 1 power and get 3? Well, it must be the reciprocal of 3, which is 1/3. Because 1/3 to the negative 1 power is 3. So that must mean that our base is 1/3. And that means our equation is y equals 1/3 to the x. Let me make that neater. Probably if I don't write it in the center. So y equals 1/3, parentheses, to the x. Right? And you could also write f of x equals. That's the same meaning. F of x is just more formal. All right, so here we figured out this one. Let's do another one. And I think it's going to be exponential. Here I gave you a bunch of points. What's the equation of the graph? Now notice my graph does not go through 0, 1. It goes through 0, 4. It should go through 0, 1. That might mean that our graph is shifted up 3. Let's try to figure out our base. All right, so notice, let's take a look at what's happening to our y values. All right, so first we go up by 1. All right, so to go from 4 to 5, we went up by 1. To go from 5 to 7, we went up by 2. To go from 7 to 11, we went up by 4. Notice we're doubling each time. If we're doubling each time, the base must equal 2. So that's going to give us the equation. Trying to get rid of the box, there we go. That's going to give us the equation y equals 2 to the x. But y equals 2 to the x has a horizontal asymptote of y equals 0, right? And we definitely are shifted up 3. Notice, see how we're even leveling right here. So it looks like our horizontal asymptote is y equals 3. So if our horizontal asymptote is y equals 3, then our equation must be y equals 2 to the x plus 3. So that's our equation. Let's see if it checks out with our points. All right, so I'm just going to plug them in. 5 equals 2 to the first, so x, y. x, y, x, y. Right? And we're plugging them into, maybe I should write the equation over here. Y equals 2 to the x plus 3. So 5 equals 2 to the first plus 3. Well, 2 to the first, that's just 2. So 2 plus 3 does equal 5. Let's try the next one. So we have 7 equals 2 squared plus 3. 2 squared is 4. 4 plus 3 is 7. That checks out. And let's try 311. So 11 equals 2 cubed plus 3. Right? Well, 2 cubed is 8. So 11 equals 8 plus 3. Checks out. Right? 11 equals 11. So we can feel really confident, because all our points worked out, that our equation here is y equals 2 to the x plus 3. So look for things like your graph leveling off. That's a horizontal asymptote. Look for your y-intercept. If it's not 0, 1, you've been shifted. Right? If your graph is leveling off above the x-axis and you don't go through 0, 1, then you've been shifted vertically. If your graph is still going through, is still leveling off at y equals 0, right? But you're not going through 0, 1, then perhaps you're shifted horizontally. We might see what that looks like. All right, here we have another graph. Notice that our horizontal asymptote is y equals 0. So we are definitely not shifted up. But I am not going through the point 0, 1. I am going through the point 0, 3. So this graph is not vertically shifted. And we know that because the horizontal asymptote is y equals 0. Right? So the asymptote shifts up just like that point shifts up. But notice we have a point -1, 0. Let's see what happens if we would move that over here to 1, 0. So notice that our next point goes up 2 to the right 1. Let's go up 2 to the right 1. And the point after that goes up 1, 2, 3, 4, 5, 6, and then one more to the right. So 1, 2, 3, 4, 5, 6, and one more to the right. So now we see the point here, 3, 1. So what raised to the first power would give us 3, right? Because this is the exponent and this is the result. Well, that would be 3 to the first power gives us 3. Notice we have now in our green graph where we shifted it over 1, we have the point 2, 9. So what could I raise to the second power and get 9? Well, that's 3. Another way you can tell, look what's happening to our points. All right? So first we're going up by 2, and then we're going up by 6. Right? Our y values are tripling each time. 2 t's and tripling? I don't think so. That doesn't look right. It still doesn't look right, but I'll go with it. So that means our base is 3. We're shifted, right? We don't go through the point 1, 0. Since we go through -1, 0 instead of 0, 1. Wait, did I write -1, 0? That's not -1, 0. That's -1, 1. Well, my graph is Other than everything I've said is correct, other than writing down 1 instead of a 0 instead of a 1. It wasn't until I wrote it down that I realized, hey, wait a minute, that's negative 1, 1. So since we go through negative 1, 1 instead of 0, 1, right, same y body there, the graph is shifted 1 left. When we shift left, we add to x. So that means our equation, by the way, feel free to take notes, feel free to cut and paste it, whatever you want to help you review. All right, so the equation is going to be y, or f of x, equals 3 is our base, and since we have to add to x, I'll put parentheses, so it looks like an exponent. So we have, so break down your graph. Look at the points you're supposed to go through. What do you go through instead? Which way did the graph move? Right? So when we realized we didn't go through 0, 1, we went through negative 1, 1, we could tell we shifted 1 to the left. That means we have to add 1 to x. Our values are tripling each time. That means our base is 3. Right? Our horizontal asymptote is 0. We're not vertically shifted at all. So that means that we just have a horizontal shift, no vertical shift. And there you go. I think that was the last of the figuring out the, or maybe there's one more, figuring out a graph. Oh no, that was the last of writing the equations. This one's a matching. Which is the graph of f of x equals, those boxes bother me, f of x equals log x plus 2 plus 4. All right, so again, this is base 10. Because no base is written. This is growth, because 10 is greater than 1. All right, so our function should be increasing. From left to right. That's growth. Are all our functions increasing from left to right? Sorry, these are a little small, so I could get all 4 of them. Well, notice the one I'm writing right next to is not. This is decay. Right? It's either decay, and the effects would be the same. So decay or negative coefficient. They would be exactly the same. Right? So if I had y equals negative log x, or I had y equals log 1/10 x, they're going to be the same. They're both decay. They both are reflected. They both go down. So that one is decay. So this one is a no. This here is referring to this equation. That was growth. This is decay, or negative coefficient. Either way, that is not what we have. We have our coefficient here is just 1. That's positive. Right? We're growth. We should be going up left to right. This is wrong. No. So now we're left with 2 graphs. Right? Those are both growth. Let's graph what y, so the base graph is y equals log x. Let's graph that and see what that looks like. So that should go through the point, whoops, I forgot, that's 5, not 1. I'm just looking at the lines, not the numbers, so like that right there. All right, so that would be 1, 0, and then 10, 1. Right? Because if I raise, if my exponent, so the y is the exponent, right? So this is 1, 0. So 10 to the 0 power is 1. 10 to the first power is 10, and our base here is 10. So here would be our graph. Oh, let me not graph in red. Let me graph in something else. So notice that this graph is shifted right and down. Oops. Wait. Oh, that's a minus. Good. I have a chain that's blocking it. I couldn't tell if it was a minus or a plus. So that's shifted right and down. But our graph here, plus 2, is shifted left and down. So this is the wrong way. So this is wrong. It's supposed to be shifted left. Let's see this one. This one is right. All right, so our base graph would go through the point 1, 0, because 10 to the 0 power is 1, and 10, 1, because 10 to the first power is 10. So there's the base graph. Oops. No, that's not too bad. And this graph is shifted left and down. And that matches. This is the correct one. Yes. That one went the right direction, and it's not going down left to right. Right? So that's how you can break it down. Look at which way your graph is shifting. You can always graph your base graph to help you out. Right? And if it's positive coefficient and a base that's greater than 1, it should not be going down left to right. All right, we got 2 quick problems. What is the domain and range of f of x equals 2 times 5 to the x plus 3? Well, the domain of all exponential functions is negative infinity to infinity, so that's easy. The range, right? So it's going to be, so if starting value is positive and no vertical shift, the range is 0 to infinity. If the starting value is negative and no vertical shift, the range is negative infinity to 0. If there is a vertical shift, regardless of whether the starting value is positive or negative, switch 0 with the vertical shift. So here I have no vertical shift. There's nothing added to the whole function. I just have, this is a horizontal shift. This is left 3. That does not change our range. It doesn't change our horizontal asymptote, and it doesn't change our range. 0 to infinity. Here, this plus, so now in the second example, we have f of x equals 2 times 5 to the x plus 3. This is added to the whole function. This is a vertical shift. So this is moving down up 3. So we're going to replace, our domain won't change, negative infinity to infinity for all exponential functions. But since we're going to replace the 0 in the range with a 3. Now our starting value is positive, right, so that's our starting value, 2. Right, so that's positive. So instead of 0 to infinity, we're going to replace it with this 3. 3 to infinity. and that's all there is. So a vertical shift will change your range and your horizontal asymptote. Horizontal shift doesn't do a thing to the range or the horizontal asymptote. Okay? One last problem. What's the equation of the asymptotes? All right, so for the exponential, what we add to the whole function changes our horizontal asymptote. Here, so the vertical shift affects the horizontal asymptote, in other words, for the exponential functions. For the log functions, the horizontal shift affects the vertical asymptotes, right? Because logs have vertical asymptotes. If we move horizontal, if our function is shifted horizontally, it's going to change our vertical asymptote. So remember what the form looks like. Y equals log, and then whatever our base is, x minus h plus k. All right, so if we have x minus h, that's h units right. If we have x plus h, that's h units left. And while the k is not going to affect our vertical asymptote, it's just going to move the graph up and down. Vertical shift affects exponential. All right, so that means our the equation of our asymptote is going to be x equals 5, right? Because we moved to the right 5. Here we have a negative in front, not going to change, so the coefficient doesn't change. Vertical asymptote. Changes the direction it's going to go down left to right, but it's not going to change its vertical asymptote. Here we have an x, this was an x minus 5, we moved 5 to the right. We have an x plus 12, we're going to move 12 to the left. All right, so this is shifts, maybe I should write that in, shifts 5 right. This is shifts 12 left, and that means our vertical asymptote is x equals negative 12. Let me write that neater. X equals negative 12. And by the way, a horizontal line is y equals, a vertical line is x equals. And that's it. So this took a little longer, but writing equations of graphs is a little tricky. All right, so I hope this helps, and good luck on your formative. All right, thanks for watching. Bye for now.